On in just a moment, and sorry in advance that the chats still aren't showing. I'm surprised they haven't fixed it yet, but I will file a bug probably next week if they don't fix it before then. Looks like we're going on YouTube. I really dislike the YouTube stream page because even if you pop out the chat, it takes up a bunch of your window, which is very stupid. I'm just pausing my windows. All right. It's 2 o'clock on the dot, and I think we're going. Pause preview. How's it look? Am I smooth? Hi, NetVentive. Hello. On YouTube chats. I don't see anybody in Discord yet. If you want to join the Discord, you can go to the URL adafru.it/discord. And we'll wait just a smidge longer here before we get going. I have my OBS further to the right now, so when I'm looking that way, that's what I'm looking at. All right, let's get going. It's 2:01. Hello, everybody. My name is Scott. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out in New York City. Hopefully I'm not too loud. I did turn it up. Some setting got turned down. I work in Seattle, so I work remotely for them. And I work on CircuitPython, which is open source software designed to run on little tiny computers called microcontrollers. I think this is what I showed last week. But this is a ESP32S3 Feather. This one has a screen on the front, and so the microcontroller, the computer itself, is under this little chip there, and it's kind of a system on a chip. So it's got RAM and non-volatile storage. It's got flash storage, kind of all under there. And it shows up as a CircuitPy drive, and you can just edit the code on there. So I work on CircuitPython, and a lot of what I do is I bring new functionality to CircuitPython, and I bring CircuitPython to new chips, usually. And then this is a deep dive where I am talking about the things that I've been working on in the past week. Oh, Mark points out that Discord was having issues earlier. That's true. I had trouble getting on when I restarted, but now I'm on Discord. The YouTube chat is set up to show up on the stream when I'm showing my desktop because I just have a window. But my OBS browser plugin is still crashing all of OBS for me, so I had to disable it again. So deep dives, this is an hour-long whatever I've been working on, and I like to show off whatever I've been working on. These last few weeks have been kind of interesting. Well, it's good. It's been a weird year because I've been doing a lot of LLM agentic coding stuff, and then I realized that I really could use some hardware for doing automated testing, because automated testing is it's easier to do because we can generate more code to do it, and more valuable because not only are we going to do it for regression testing, but we can actually do it for feature testing in the LLM loop. So generate some code or fix some things, and then be able to push it to devices and make sure that it still works. So I'm excited about that. It's going to be a big project, but my understanding of the crux of using LLMs, large language models, to generate code is that they're really good at that because they have these automatic feedbacks. So my canonical example has been we have an Espressif port of CircuitPython, and I've updated from version 5 to version 6. And I could tell the LLM, hey, compile this board, make sure it compiles. And then it learns how to run that command, and it can get automatic feedback to know if it needs to change things or it changed things incorrectly. So that's super powerful, and I want to get the actual hardware in that loop. So once you get it compiling, loaded on all these boards via this mechanic or this transport, and validate that the things that should work still work. And if they don't, fix them automatically. So I've been in hardware land. I have never really done a lot of hardware for Adafruit because I'm mostly a software person. But I just had this idea that I was like, I really want to do hardware in the loop. And I have this other board that was like somebody's thought about, but it's not quite the way that I would do it. And I'm guilty of wanting to do things my own way. Also, the ESP32P4 is really good for this. And so I've been doing board design rather than software. So first, before I switch to the desktop, let me show you. Because the first board design I did actually came back from JLC. And I think if I hit this button, we go into product showcase mode. So this is, I'll flip it upside down so that the text is right set up. I'm calling this the P4HIL. And this is a board designed for the ESP32P4. And the goal is to break out as much GPIO as we can. Because one cool thing about the P4 is that it has 55 GPIO. However, some of those, hello Beata, are they doing the assembly for you? Yes. So this is produced at JLC and also assembled. The only things that I've put on here are the headers. I soldered all the headers yesterday, and I did the jumper wire to make it actually work. Because you can never get it right the first time. So what's this board have? I'm backwards, so this board has two USBs. One is the high-speed USB, and one is the USB to serial JTAG. That takes two, the serial to JTAG USB takes two of those 55 GPIO. The high-speed USB pins are on dedicated pins. So that you lose two there. And then there's two bootstrapping ones, and then a NeoPixel one. So I got 48 I/O out, so I have 6 headers of 8 pins. Hello, DCD. And so I got the board back. I ordered it. I looked this up. I ordered it 2 weeks ago yesterday, so it took 2 weeks to get manufactured and assembled and sent to me, which is felt like a long time, but it's also kind of amazing. And that included me waiting 2 days to get back to them on the review stuff that they asked me to do. So when I first got these boards, I didn't have the headers on, like I said, and I plugged them in, and I was able to talk over both the USBs, both of these USBs, to the ESP32P4. However, I wasn't able to load code. So when I would do a flash command, it would look like it flashed, and then it would do an MD5 sum or some sort of checksum over it and say they don't match. And when I looked at it yesterday, I realized that I had forgotten to connect to the power. So the ESP32P4 has its own regulator to give you the voltage that you need for the flash, which is actually the same voltage that I'm putting into the P4, but it has the ability to do 1.8 if you want to do 1.8 instead. And so that's coming out over here. And I thought that there was a thing in the chip where it would take it to, there's another power pin over here, and it would output of that other pin. But the reality is that that was actually that's a power input for the I/O voltage to go to the flash. So I failed to connect those two things. And so that's why I have the yellow jumper wire, and now it works. So I can actually grab this USB cord, and you'll be able to see that we get a bright green LED, and the NeoPixel over here also flashed. And then we had two buttons. One is boot, one is reset. And you can see where CircuitPython is running on this, so it's doing the green flash once every 5 seconds that the program is done. There's a stem QT on the end in case you just want to add anything else. But those are the main things this board has. Is it's got all the GPIO, the NeoPixel, the two buttons, the two USBs, and the flash needs to work. So I feel like this is pretty much done. The only other thing that I realized, well, one, I think the green LED is too bright, so I'm upping the resistor value for that. Right now it's 2.2K, and I think in the next version I'll do 5.1K, which is the same value that I'm using on the USB lines. Actually, I can hold it closer. Giant picture of that. So that's version 1. And then the other thing that I wanted to do is I went to plug in both USBs and actually had a lot of trouble. Let me find. This one actually fit next to it, but I actually had trouble. So there's one in here, and this one's not plugged in, but it's actually quite close. You can see that they're touching there. And I realized I had a little bit more wiggle room because I didn't align this. This one up here is like almost near the edge, like with the boundary that we want to leave. But this bottom one is actually further away from the edge by a little bit. And so I've moved the USBs as far apart as I can just to give more connector room there. Any questions about this board? I've been pretty happy with it, and it's going to be a good one for, oh, the other thing I should show is what it was designed for. So imagine you have a breadboard. So why is it this these sets of 8? Well, what you can do, and it does work this way, is you can plug in 16 pins like that and hang it off of a breadboard and not use your whole half-size breadboard to fit this on there. And that's why I have these 4 sets, or these 4 pins. It's the same 4 pins on each side. It's ground, boot, reset, and 3.3 volt power. And that the idea there is that you can use a jumper to get it to the rails here. So that's what I'm calling the P4 GPIO board. And this was really also a board for me to like figure out all of the ESP32P4 stuff. And this is a version 1.3 of the chip. So the other thing I had trouble with yesterday was that it is that ESP IDF6 assumes that you're doing version 3, whereas this is a version 1, and so I like messed that up with CircuitPython, and I had to fix that, which has been merged in. And this version of the board has been merged in as well, so you can see it there. Yeah, Mark had said jumper wires are required for Rev 1. Yeah, but I did do the jumper wires on all 5 of them that I got ordered, and they do all 5 of them work, which is good. And I kind of want to use those as the logic analyzer stuff too that I was doing. In fact, maybe that makes me want to do a smaller board that's just that. Maybe. Okay, so what am I working on now? Well, I have a revision. Like I said, I did a revision of that board, and it's pretty much done. Tyeth asks, so this is effectively the logic analyzer without the extra USB and hub and GPIO expander. So this is more, yeah, this is more just the like logic analyzer, more minimal board. And then the other board that I've been working on that I've been showing off is this one that I'm calling the P4HIL, hardware in the loop board. So let's actually view the 3D viewer, because I think it's a little bit friendlier of a version of it. So this is kind of a, this is starting from that. So I started with like a design block of here, and I have to update this to fix the voltage, or the flash voltage. So I'm gonna have to do that. And then there's some extra stuff here. One thing that I'm like less certain about is getting Ethernet working. And that actually used a lot of pins. It's like 9 pins, 10 pins for the Ethernet, which is unfortunate. So I was able to do, well, I did 20 on the bottom, 19 on the top. It was 20 on the top, and then I was like, oh, I need 1 extra, so I'll just make it 20 instead of 19, or 19 instead of 20. And then as I was like finishing up routing, I realized that there's some circuitry. Let's see, this circuitry is the 3.3 volt regulator, but on the back here, I think it's on the back. This circuitry here is the switch IC that connects to, there's a bunch of resistors, one of these resistors is a protection resistor, and two of them are pull-up resistors, so that you can test I squared C. And I realized it wasn't connected. I needed one more pin, and I was like I could have done 20 and 20 if I had given up and put an IO expander from the start. But I decided not to, and I was like almost done routing, so I was like, okay, I'm not gonna worry about swapping that. Maybe in another revision I will. And I put this is the circuitry for the Ethernet chip here, and it needs its own crystal. I put it on the back because it meant that I didn't have to. I could route these pins straight away to the connector. I didn't like if it was on the top, it would have to have swapped. So yeah, so this is like the P4 GPIO. So it's still trying to break out as much GPIO as possible. It's 19 on the top, so T. I'm calling it 2 through 20. 2 through 20 here because column 1 is dropped. DCD says, so the hardware loop board will have headers installed to plug into like the breadboard. So no, you'll have to solder the headers where you need them, is what I'm thinking. So this example right now is showing some of the headers. I would put headers here if I had it right. If you were plugged into an Arduino as a shield. These are the headers, and this is where I would put them. I would put them on the bottom. If you're doing it at like a dual row, and I tried to draw this on here, that you put, like if you have a trinket, you put it here. If you have a cutie pie, it goes here. And what I'm imagining, but when used, there will be headers, right? I'm assuming you're going to use headers. And part of the reason I assume you're going to use headers is because there are components under here that you're going to want to lift your device under test for. So like say I'm doing a cutie pie, I feel like I'd put like a female header here and a female header here so that like I could plug any cutie pie into it, or feather here and here. Like I imagine that like I will have to solder headers for the particular thing that I want to plug in. But I'm assuming that I'm going to plug it in so I can like pop the device under test off of it and on it. So like I could do 3 that are feather form factors, and if I need to, I could swap the device under test. And the USB, so this here is designed for a double USB-A stacked connector. So that will, in my first version at least, I'll solder that on. Same with this Ethernet jack. Like I don't care to pay them to do the hand soldering. Like I don't mind doing the hand soldering. In fact, like for the barrel jack, I'll only solder the barrel jack on if I want to do that route. Taya says, are you tempted to get a few copies fully populated with female headers? Not really, actually. I hadn't thought about that. I guess part of it's just I think it's expensive. And I think it's expensive, and I'm not seeing this as like I'm going to have one and I'm going to put everything on it. It's literally I'm going to have like a lot, and then they're just going to live with the particular dev board that's on it. Because the goal is to have like, I always have an ESP32 C6 handy to test with, right? Like I always have this thing that's just plugged in, and like I have a script that can say like, run this thing on an ESP32 C6, and here's the firmware, and here's the flash image, and blah, 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 right? Like, I want to have a harness where I can just kind of farm off to it. And to that end, like, since I always want it plugged in, like, the interface chip here for the Ethernet can actually do wake on LAN detection. So I have, it's shared with the NeoPixel, but like if you go to sleep, you can actually like have this wake you up if you configure it right. So that's something that maybe if we do have like a lot of these, we'll end up doing. And then I have power options as well. So kind of like the first one to start with is just USB power. and there's a header here to connect the USB power to the 5 volts in, and then that 5 volt goes down here to get 3.3, and then these are 2 switches for 3.3 and 5. They then go through, this is an INA 290, I forget what it is, current sensing thing, so it can tell you like the current through this giant resistor, and this giant and that power then goes up this way to the USB headers. So the switched power is the USB hub, and the USB hub takes 3, 3, and 5, and then 5 volts goes out the 2 USB headers here. TCD says, do you envision needing hooks or instrumentation in the CircuitPython code that is being tested, or is it a requirement that the full hardware in the loop testing runs a pristine CircuitPython binary? That's a good question. Yes, generally I'm thinking of it as like external, like nothing special in the CircuitPython binary. The things I was mainly considering where I think that might not be true is how you load the code that you're going to run, like the Python code that you're going to run, because like for every test run you're loading CircuitPython, and then you're going to load like multiple images of the CircuitPy drive, and that's like a lot of flash erase time and test time. And so I was like briefly thinking about ways of like storing it in like maybe in a RAM that's acting like a flash, so that like you're not actually paying the flash cost. But then that like takes time to like, now your hardware is not truly what the hardware is, and these boards are pretty cheap, so optimizing for like flashware is not actually that important. Hamzab says, hi Scott, I'm a bit late. I'll have to circle back later to see what this is about. This is the current state of the hardware in the loop board. So it's fully routed, it's fully DRC'd, although I think I've updated the schematic for the flash fix that I have from the other board, but I have not routed it yet, so I do have to fix that. I was just tweaking all of the silkscreen. I do silkscreen kind of last. The reason I like to do silkscreen last is because you want to avoid components. So like, for example, here, the 11 and 12 are above where these resistors are. I can't put the resistors closer because there's like traces being fanned out, but you can put silkscreen over traces just fine. This is a USB header that I put here, and I have a label. I've labeled all these. And just before I was getting on the stream, I realized I had to label all these things on the right-hand side. And the left-hand side, I don't have room to label this header or this header. And these are the headers that are broken out for the extra GPIO from the expander. So it's like not super important, although now I realize as I'm saying that, I could actually just do it on the back. I have not done any labeling on the back. And maybe I should, especially the Arduino stuff. Is this for Adafruit internal use, or will it be sold to peeps like us? I think it will be stocked. That's a question for Lamore. I'm sure she may change it. But yeah, like it's all open source. So, you know, depending on how much you want to spend, you could order it off JLC like after I've done it. All of the files for ordering from JLC I do just commit. But a lot of the cost for like getting 5 is like setup time. One of the challenges, or one of the unfortunate things about this, is that they have like 2 levels of assembly. They have standard and express, or something, some other term. And if you do like the express assembly, what is it called? Like if you do the like cheaper version, they like have standard parts. And like if you do basic parts, then it doesn't cost you money to put the feeders in the machines because they just like always have the basic parts in the machines. But the problem is that the ESP32P4 is only standard assembly. So you end up paying like $3 per unique item, even if so if you look here, you can see that it's like PCBA type standard only. And this is just like, I guess, package constraints, which means that like your whole build is standard. And so you end up paying for even like putting the resistors in the feeder. So I think it was like $60 or something of like, I ended up spending like $300 to get those test boards. And like $60 was just like feeder fees of putting those in. And of course, like if you do a large order, all of that setup cost gets amortized over all of the boards. But I don't want to order a bunch of boards that like one, I'm going to revise, and two, like may not work. So I just did 5. But let's see, what's it? I still didn't find that other term. So, oh, economic. PCBA type economic versus standard. And economic is like if you have these basic parts, then you don't pay feeder fees. You just pay for the components. But because of the P4, like you do standard assembly for everything, which is a bit unfortunate. So yeah, I assume that Lemore's game for selling it once we've used it and validated it, and maybe she'll do a bigger order. But also, like, it's all just on my GitHub. If you want to buy it kind of more expensive, that's totally fine too. I wouldn't buy this yet. Like, wait until I get it back and make sure that like the Ethernet stuff works. And like maybe something I should do like in that 2-week period between when I order it and when I get it is like validating, like actually get the software side ready for this stuff. But yeah, ultimately it's not my decision on whether we sell it, but I mean, I'm putting the work in. I don't, unless she didn't want to support it, then I don't think she would, but I don't know. I think the plan is to make it available because like Lemore recognizes the value of this. I was like quite surprised, like had an internal meeting with her on Monday, and I was like, like I'm doing all this hardware stuff and I'm really a software person. Like I could get back to doing this thing or that thing. And she was like, no, like keep working on the hardware in the loop thing because that's going to like feed back and like make everything easier. So yeah, I think it seems like she agrees with me that I've hit on something that could be really valuable. And sometimes she's like, oh yeah, sure, like do that a little while, but don't get too lost in it. And this one, she's like, no, I think you're right. I think we need it. So, so that's exciting. Like she's got a very, very good taste and feel for stuff like that. So, I think I've covered this before. This is a motherboard header for USB. So like 2 of them are on the USB A's and 2 of them will be on this. Tyed says, are the CSI and DSI pins for the P4 effectively consumed? Curious about my camera add-on needs. No, so those are dedicated pins that I'm just actually I haven't used yet. I don't know how hard they're going to be to break out, but if you look here, there's no pins coming out of here, and those are the CSI DSI ones. So I haven't explored that yet. But yeah, those pins are dedicated pins, and I'm just not using them. So power options, USB, and then there's this thing called passive PoE, which is not real PoE. But you can use the extra pairs in the Ethernet to put power down them. So this is a header here where you can say like, oh, 7 and 8 is ground, or 7 and 8 is V+, and then DC barrel jack, you can connect to V+ as well. So I didn't want to do like fancy circuitry to automatically select between these. There's just jumper headers here to like fix which power source you're going to be powering it on. And if you're doing the V plus thing, then, and I realize I don't have a, oh yeah, if you want to do, if V plus ends up being 5 volts, you can bridge it here. But then this is a spot here for an external regulator breakout that you can like get in the shop. Or a TO220 or something can go in this spot too. Maybe the extra pins can be broken out to test points. Is there room? Which extra pins? Are you talking about CSI, DSI? Those wouldn't really help you. The extra I/O expander pins are on this header and this bottom header. The CSI, DSI, I don't think you're going to want to do them on test points anyway because they're like high-speed differential signals. I'm not trying to bite off more than I can chew. Which is kind of a unfair thing to say because I feel like I've bitten off a lot because I'm doing like Ethernet and USB hosts. So I've bitten off a lot already. And there's a lot of routing to this board. Like if we look at so it's a 4-layer board. And actually, we can fix the thing. So I tried to do power on the outside, and then we also have a ground plane. So big fat power traces, because I'm thinking like we're a root hub. So we got to get as much power as we can to our USB devices. So our switched 5 volts goes out this way. After it goes through, goes past the resistor for the INA219, and then there's 2 power switches here, and then 5 volt power goes into 3 volts, and then all of these boards are connected, plus you also are running lines down to the bottom row. And then if we look at the layers here, so the back isn't as bad. There's still like traces going this way and this 5 volt trace here. And then there's also a middle trace. So this is an inner layer. So this is half an ounce copper versus 1 on the outsides. And this is more getting like 3 volts more places. These pads here are the LEDs. And I've got to figure out LED resistor values. I haven't done that yet. The other thing is we haven't done where's the power? My power. VDD flash. So I haven't fixed the flash power yet. I've got to run it. Usually I run it that way. I think is what I did. Did I go that way? No, I went the other way. So here and then this way. So I'm gonna have to route that. So why don't I gotta do that. So I'm thinking about it right now. So let's go to the schematic. Let me shrink it so you can see it. So let's check that the schematic has been up to date in, close the design block editor. So this is the top level of the schematic. This is the P4 with the pins broken out. I2C pull-ups, 2 buttons for boot and reset. Stemic UT header, NeoPixel. And then over here we have the IO expander and the IO headers. And then we have sub-pages for the power stuff, Ethernet stuff, USB device, USB host, the test pads for the device under test, and the pull-ups for that, and then the ESP32P4. And this is the thing that has a design block in it. So if I click this, this is a group, and this group was imported from the shared thing. And so here, this used to be VDD-O flash, and it wouldn't be the same name as the flash over here. But I've fixed that, so now what we should do is update PCB. And there's a bunch of group stuff, but we'll update it. And now we can see that we got this one faint wire here. And if we run the DRC, so design rules checker, we can just see how we're doing on that. So I do this before silkscreen clearance, clipped by solder mask. So I added a bunch of silkscreen, and so I am seeing silkscreen that needs to move. But the things you really want to address are the unconnected items. Hi, Jono. And schematic parity. So duplicate footprints, extra footprint. Those are just the four corners footprints. But here it says that, like, oh, by the way, VDD flash is not connected. So let's do that right now. And we're going to do it. We're going to figure out how to do it. I don't know what to do about B13. Because last time what I did is in the other version for this other board, I deleted this ground, went here, via down, and then out this way. This can probably scooch enough. So this is, let's delete this. So I had to double click to get into the ground, and maybe let's worry about B13. I hit escape. Let's just, like, it's more important that we get the power than the flash. So we'll fix B13 after we do this. So I'm going to do X to go into that, and then V for via. Yeah, I guess I can put this as far over that way, but then I still have this problem. Do I want to route it on the back? I don't think I do. I would rather route it inside. And I want to route it pretty fat. That's not pretty fat. I was having this problem. 2 millimeters, let's see if we could do 6. One cool trick is that I routed it right under the pads. Yeah. So under the pads, over to here. And I have push and shove routing on. That's what's, can I shove that out of the way? I can, great. So we're going around. Here's all those CSI DSI machines. HamsLab says, how much do you use an AI agent to help with PCBs? Not as much as I would like. I've felt like very slow the last few weeks because I've not been using AI agents. I have been using Claude a lot for like, oh, like what resistor value should I do, or like questions like that. But it hasn't been like, I've tried a couple times to get like it to help me with actual like the PCBs of like, oh, like I'm making net labels that match the pin names, like, and that should be easy, and it just failed miserably, unfortunately. So there we go. And now that I see that it's routed that well, I kind of might make it even fatter, just because like we have the room. Although I guess I have 0.762. So the inner layer is actually not, oh, okay. mils. It doesn't matter that much. It's not actually that much current. I don't think. It's like 25 milliamps. I think that'll be fine. This via probably limits it more. The other question is like, okay, how do I get B13 connected up again? So HamsLab, the question you have is like not that much. Phil and Lamore are actually doing more exploration around this, and I'm curious to see what comes of that. And now that I'm looking at this, I'm tempted to just go bloop and have B13 go around the flash. So let's not have it 80 mils. We'll use the net class width, and let's just see if we can't scooch in there. Come on, push and shove. Nope. But we can hit D for drag and see. Nope. We may not have any room here. Let's see if we can make some room. We pull that one up. Pull this one over. And then this over. And sometimes there's like other segments in here that I don't think that's enough space. We can try it. Let's see if push and shove can get through there now. Oh, we can. Great. Via. V for via. And to the pad. All right. So we wove it there through, and now our flash is connected. We can hit save and run DRC again. Right. Yeah, I wonder if the AI can provide trace width guidance for that flash power trace. Yes. I asked that, and I think it, you know what, we can just, I think I have a past chat with Claude about this. Oh, I was asking like, oh, they were V-scored, I-square. Oh yeah, 30 gauge wire capacity for 25 milliamps. So the yellow wire the yellow bodge wire is 30 gauge. And I was like, is that big enough for all of the flash power? And it's like, yeah. Ty says, it's a lot of crazy routing, impressive, intimidating. I tried Flux.ai for those kinds of things, component and trace device. It did it, but 8 tokens like a madman. Yeah, I don't know where I'm at on my subscription for Claude. I feel like I'm definitely haven't been using it because I haven't been generating code. But I have, as you can see, like the things that I've been asking it of like green LED resistor value and like cheapest IO expander. And I was figuring out like how much clearance I need for hex standoffs for like, because they're 2.5 millimeter like M2.5 stuff, and we're like, okay, like if they're 4.5 millimeters tall, like what is the circumference or the diameter of that, and like figuring out extra. Yeah, Mark says I'll take your extra tokens. Don't worry, I do want to use them. So yeah, this is more how I've been using it. I've tried it just a couple times, and yeah, it's just not been, still figuring it out. Still figuring out how to actually like get it actively helping me with this stuff. Okay, so VDD flash was run. Did we run the DRC? Maybe I closed it. Let's run it again. So here's our unconnected items warning, but now we can run DRC. And now it says 0 unconnected items. There are duplicate footprints and extra footprints. But what we could actually do is, I think if we go in here and just say on this footprint, it's not in the schematic. It's just a mounting hole. One thing that I've started doing more is like, okay, I'm just dealing with footprints. So over here you can uncheck it. I know you can't see it. Sorry. So this is a selection filter, and sometimes it's really frustrating of like, oh, I don't want to click that, but actually it's really nice to just say, okay, right now I'm dealing with just footprints, and like I just get the mounting hole. I hit E for edit, say not in the schematic. Not in the schematic. And now I hit save, and I pull up my DRC. Oh, I close the DRC window. And I can run it again. And now I've only got my extra footprint for my chickadee, which I always like to sneak on boards that I design, which is a copper layer for my thing, and I could just say that's not in the schematic either. And then that makes that warning go away. We do have like 47 violations, which is actually a lot. So let's see. Oh yeah, we're missing this eye to this resistor. So in this case, what we can do is we can, I think we can just drag it. Oh yeah, we could drag it, but it didn't bring the wires with it. I wonder if there's a, yeah, I hit D with the component, and now it's actually dragging the wires itself, which is awesome. Okay, so now we've moved that resistor away. This one here is also, so we can, so these, I don't know why that moved. I don't really care about the silkscreen. I don't actually care that much about these silkscreen warnings. It's just like a note here. Like it'll automatically get clipped. But it's also like good policy, I feel like, to just be better about making it not overlap. Oh, come on. The snapping is just like driving me a little bonkers. Uh-oh, I think I'm crashing. I'm on like the second. I've been having some crashing issues with Kicad 10. See, like, it's not responsive to me anymore, which is a sign that something is hung. DCD says, which warnings will cause you to have to communicate with JLCPCB? Definitely, well, they have a couple boxes you can check to make sure that like they will take a brief check for everything. One box I do check is that they make sure that the placements are correct, and they will fudge everything to get it lined up better, which is like very handy to just have a second set of eyes. It does mean that you have to watch your email to make sure that you see the email where they're like, hey, we changed stuff, can you make sure it's right? Otherwise you could lose a day to get it done. I don't know why I think I'm hung. Oops. Yeah, it's not closing. Well, it's not crashing. It's just not working anymore. I have had some problems with Kicad crashing. Did I save it after I ran that? Let's see. I think I did. Sure. It said autosave. And let's look at I see the orange trace here. And the thing that we were trying to fix is this. Although I have, and I realize you can't see, let me put it back up here. Any questions? Because we are just about getting there. Let's see if I can, like the snapping is just, I was trying to remember. The graphic snapping has been messing me up. So I've shortened that one, and then over on this side I can do the same thing. So the angle will tell me if I'm not. So if I do that, then I can run DRC again, and the number of violations will go down. And I had to pop up the schematic, and now we're at 38. And I did this deliberately, I think. I deliberately kind of like that they touch, because they are associated with that. So one thing you can do is, in the DRC, silkscreen clearance. So you can also just say, ignore all these. And they go under this ignored test, and now we only have 12 violations. Insufficient stroke width. Oh yeah, so we can select this and just do bold. Now we get something that's a little easier to read, hopefully. And this layout is meant to mimic this 5x10. It's the same layout as the motherboard USB headers. And there's something clipped by the board edge. I think it's generally good policy to try to get rid of all of these. Here we go. So this we could probably just scooch. Like, it's gonna be a little close, but that's right. Again, I think it's good to have it. Not warn me. So now how do I run it? Oh, so the last thing I need to do. Okay, we got 8 minutes. Another thing I wanted to do was board edge. This one. Okay. Oh yeah, I meant to. Y and 39197. This one. $39,197. I had the wrong one. The 53. I'm like, one thing that I've discovered with doing PCBs is that I zoom in and I get all the details exactly right, and then then it comes back and it's a little tiny thing. And I was like, oh no, okay. So that's that warning. The last thing I want to do, we just have a few more minutes, but so these are silkscreen clipped by soldermask, which we can find here. A few arrows. Oh, this line here. I'm watching the angle. So the D is the way to do it. Although the D can't rotate. But it moves it around. That is pretty cool. This one, I didn't know. I moved it out of the way of the Pico. I think that's fine. Okay, the last thing I wanted to do, or one thing I wanted to do that Phil's robot warned me about, is the length matching. So these RMII things are high-speed signals, so they're like 50 megahertz, and if you don't match them lengthwise, you may end up doing you may end up getting like missed bits. So tune length of a single track. So what's a phrase you didn't expect to hear? So now we can say, okay, this current length is 24.3756 millimeters, and then this one is 20. I'm surprised that they're not 20. And then this is, okay, I don't want to see, I only want to see the red ones, because I just have them on the red ones. So clock is 24. TXD1. Look, I have it hidden and it's still doing, oh, RXD0 still, 29. So I think what you want to do is you want to make them 27. You want to make them all the same length. 19. Oh yeah, what Phil's robot said and told me to do. Yeah, he's been playing around with like some automated PCB design review stuff, which I don't know if he's showing off yet. But. So this one's 29. This one's 27. So maybe, I don't know how this works. That one's quite long. Huh. I'm not exactly sure how to tune all to like a target length. I've not done this tuning before. I know you can do it. Oh, so just like add some wiggles. So we're like trying to get it to be, well, 29, right? Like this one is 29. And if we're going for all of them to be 29, I wish I could. This one's 25, so if I click this, can I get some wiggles? 27, 29! But then this one goes to nowhere. No, it goes into the thing. TX enable doesn't matter. 19, this one really needs to go. Really needs to wiggle. It doesn't, it needs more room to wiggle. Okay, so I'm playing around with that. I guess I could try to make the 29 one shorter, but basically I think I need all of the data lines and the clock to be approximately the same length, or like as close to the same length as I can reasonably get it. So I think that's one of the last things I need to do. I think I will Control C that for now. Because I think what I'll do is I'll space them all apart and then shoot for the longest one and make them all the longest one length. But I've got to figure out, like, first I can try to make the longest one shorter. So I think that's kind of what my approach will be, is make the longest one shorter, and then, like, because I can bring all these ones in. Like, this is, I wish this overlay would tell me which one it was. Like, that would be really nice if it would say, like, oh, this is CRSDV, instead of, like, just telling me the current length. But, like, if I go to the routing mode here and then I hit D, like, now I can scooch these back together. And, like, maybe I don't want to do that, but oh. All right, I'm just about done, I promise. Current length. So yeah, we dropped 2 millimeters on that one, which is good. So that's, I think, the last thing I need to, so I'll do that, and then I'll start, I've got to pick components for everything and make sure that, like, my LEDs are matched up with the right resistor values and stuff like that. So I'm getting close. I'll probably end up ordering Monday or Tuesday, just because I don't think I'm gonna do this. Well, maybe not. Maybe I'll do it tonight if I have time, because I did not do a ton of work today because I had a kid with a doctor's appointment. Okay, let's wrap up. Thank you, everybody, for joining me on this deep dive. I hope you enjoyed watching me drive Kicad and crashing it, kind of having it freeze on me. But I'm very excited about this board. I'm excited for automated testing. It's gonna be, it's not a simple thing, but I'm very excited to see what happens with that. I think I'll order 5 of these and then bring them up, make sure they work, and then order more if they work. Maybe if they work, like, the more we'll order more. We'll see. Yeah, so if you want to follow along, they're under my personal repo. So you just, or personal organization, GitHub/Tannewt, you'll see they'll be right at the top of the recent repos. If you want to support me, you can go to Adafruit.com, purchase hardware there. It supports me and all of Adafruit. So thank you to everybody who does that. If you are outside the United States, resellers are a great way to support Adafruit as well. If you want to join the Discord, you can go to the URL adafru.it/discord. You can ping me there, also Tannewt there, and I'll add you to the deep divers role if you want. That's just in case me or Tim want to just, like, give people a heads up. Like, I have 2 young children, and if I'm unable to make it, I just ping that and say, like, hey, sorry, I can't make it. And I think that's just about it. Lastly, thank you to DCD, who usually takes time codes, which now I feed into the bot, into Claude, and have it do a thumbnail for me. Although I'm going to be kind of tight on time here, so I might not do that immediately either. With that, thank you all. Have a great weekend, and I will talk to you next week. Here is the kind of nice, partly cloudy skies over Seattle here. Have a great weekend, everybody.